angles and such.
Okay, do you have some example program or problems?
Yeah. So it says find the exact value of each trigonomic function if defined. If not defined, write undefined.
Okay.
Okay. So the first one is tan of 2 pi.
So you've had the unit circle?
Yeah, so we did that whole thing. And your lesson on that really helped put me ahead by a ton.
Okay. Have you had the graphs of each trig function yet?
No, I don't think we've gone into that yet.
Okay. What's the equivalent of the tan of 2 pi? First of all, how many degrees is that?
2 pi is 360 degrees.
So it's also the equivalent of what?
0, 1.
0.
Oh, 0, sorry.
All right. The tan is equal to 0 basically when the sine is equal to 0.
Okay.
Have you had that relationship yet? In other words, the tan is equal to the sine over the cosine?
Mm-hmm.
Well,
Yeah.
the tan of 0 would be the sine of 0 divided by the cosine of 0.
Okay.
What's the sine of 0?
It is 0.
Correct. What's the cosine of 0?
1.
What's that answer? 0 divided by 1.
0.
All right.
Okay.
That's what the tan of 2 pi is. Not sure. I guess I really kind of did need to go through all of that because we didn't really talk about the tangent curve. While we're talking about it, let me draw it. Tangent curve, unlike the sine and the cosine curve, have vertical asymptotes
Okay.
where it's undefined.
Okay.
Tangent curve looks like that, and these asymptotes occur at minus pi over 2 and pi over 2. And then every pi after that. So the next one occurs at 3 pi over 2.
Okay.
And it merely repeats. And you can see that the tangent of 0 is 0.
Thank you. Okay.
Okay. All right. What else do you got?
So the next one is the cosecant of 270 degrees. And isn't 270 on the unit circle too?
It is. And that's why I'm drawing it.
Okay.
What are the coordinates of that point right there? In other words, this is 90. This is 180. That's 270. In other words, it's a quadrangle. It's a multiple of 90.
Mm-hmm.
First of all, what are the x and y coordinates of that point that I just circled?
0, -1.
And the thing you need to remember is that x is equal to cosine of theta, y is equal to the sine of theta.
Okay.
If I said, what's the cosine of 270 degrees, the answer is that, 0.
Okay.
What's the sine of 270 degrees? The answer is that, -1.
Okay.
Well, let's first of all, what's the reciprocal of cosecant?
Sine. Sine.
It's the same as 1 over sine of 270.
Oh, okay.
What's the sine of 270?
The sine of 270 is it -1?
Huh? So what's the
Okay.
cosecant of 270?
1 over -1, so that'd still be -1, right?
Correct. 1 is
Okay.
the only number whose reciprocal is itself. Every other
Okay.
number, when you take a reciprocal of it, it changes. But when you have 1 or -1, it stays the same.
Okay.
Okay? So that's kind of the way I do all of these secondary trig functions, I call them.
Mm-hmm.
They're not really secondary, but if you want to split up the 6 trig functions, the 3 that are on all calculators are sine, cosine, tangent, and the 3 that are not on most calculators are cotangent, secant, and cosecant. So
Mm-hmm.
whenever I'm talking about one of those 3 secondary trig functions, the easiest way for me to think about it is to put it in terms of sine, cosine, or tangent, which is what I did there. I put it in
Okay.
terms of sine. And then I know what the sine is of an angle based on my unit circle. I can always figure out the sines and cosines
Okay.
of these angles, whether they're quadrangles or merely multiples of 30 or 45. I can figure out the sine and cosine. Well, if I can figure out the sine and cosine, I can figure out the tangent, because tangent's sine over cosine, and I can
Mm-hmm.
also figure out the other 3 trig functions, cosecant, secant, and cotangent.
Okay.
That maybe will help you in figuring out some of these secondary functions, is to first figure out the primary function.
Mm-hmm.
What else you
Okay. I see what you're saying. Okay, the next one, it wants us to sketch each angle and then find the reference angle.
got? Okay?
And so the first one is just 210 degrees.
Now, what quadrant is that in?
The third quadrant.
Okay? What they're saying is that angle there is 210 degrees.
Mm-hmm.
And the reference angle is always, I'm going to call it alpha. It's always the angle made with the x-axis.
Okay.
If that's 210, what's alpha?
30?
Correct. In other words, here's the formulas. 180 minus theta, theta minus 180, and 360 minus theta. What
Okay.
these numbers are, I've always told you that these numbers are the equivalent first quadrant angle,
Mm-hmm.
but that's the same as the reference angle. In other words, if you, no matter what quadrant you're in, if you figure out the angle that's made with the x-axis, the acute angle,
Mm-hmm.
that will be either that, or that. In other words, with the case of 210, I'm going to take 210 minus 180, and I get 30 degrees as this angle alpha.
Okay.
Okay? So that's equal to 30. Another one.
Okay.
That's
The
all you
next
needed
one,
was what was the reference angle?
I'm sorry, I didn't catch that.
That was all you needed was what was the reference angle?
Yeah, you just want to sketch the angle and then tell us the reference angle. So the next one is 660 degrees.
All right. when you have angles that are outside of the unit circle, meaning greater than 360, what you want to do is subtract as many multiples of 360 as you can.
Okay.
And that puts it into the unit circle. Well, if I subtract exactly one multiple of 360, then I get that. Those are equivalent trig function angles.
Okay.
Whatever the 6 trig functions are for 660, they're exactly the same for 300. And in fact, they're exactly the same as minus 60. In other words, coterminal angles all have the same trig function. Coterminal being multiples of 360.
Okay.
So when I get an angle that's greater than 360, I subtract as many multiples as I can of 360 away from it to figure out what its unit circle angle would be. Well, 300, if this is 270, then that's about 300. In other words, if I draw it, that's 300. And again, alpha is that angle right there, the one made with the x-axis. Well, what's alpha? Based on this formula right there.
60?
Uh-huh. So that angle is 60 degrees. So in other words, if we had talked about this problem before when we were covering the unit circle, I would have said, well, it's the same as 300, which is correct because the equivalent first quadrant angle is 360 minus 300 or 60. So when I say equivalent first quadrant angle, that's the same as the reference angle. So I'm going to base all my calculations on a 60-degree angle, and then I'm going to use all students take calculus to tell you whether it's plus or minus.
Okay.
In other words, if I said, what's the cosine of 660 degrees? That's the same as the cosine of 300. Which is kind of the same as the cosine of 60. That's the reference angle. Cosine of 60 is 1/2. 300 is in the fourth quadrant. C means positive. So the cosine of 660 would be plus 1/2.
Okay.
Not that they asked for that, but just to reference it back to what we've been talking about.
Okay, I see. Yeah. Okay, so the next one is negative 75 degrees.
Positive angles are measured counterclockwise from the x-axis. Negative angles are measured clockwise.
Okay.
That angle right there, theta I'm going to call it this time, is equal to minus 75 degrees. Well, what's that reference angle? Remember, the reference angle is the positive angle made with the x-axis.
So it would be 105 degrees?
No.
Or would it be 15 degrees?
No. Look at my picture. Here's theta. Theta is minus 75 degrees. Well, what's the angle made with the x-axis? Plus 75 degrees.
Okay.
In other words, if I said, what is the equivalent first quadrant angle, if we're going to solve it that way, don't have to. There's two ways to solve trig functions of this angle. But when they told you to draw a picture of it and say what the reference angle is, the reference angle is positive,
Okay.
5 degrees. Remember, the reference angle is always that angle, positive. It's
Okay.
probably confusing here because the fact that I drew the arrow clockwise means that it's a negative angle, and it is. But if I were to ask you what's the equivalent first quadrant angle, it's 75 degrees.
Okay.
I'm going to base all of my trig functions on 75 degrees, and then I'm going to figure out whether they're positive or negative in the fourth quadrant, because I'm still in the fourth quadrant here.
Okay.
Okay? Even though they're not really asking you that, it's still important to know. In other words,
Okay.
negative angles are going to end up with the reference angle being the same as the absolute value of that negative angle. Well, not always. If it's in the fourth quadrant, that's true.
Mm-hmm.
Okay, what else you got?
The next one is a radian,
Okay,
and it is 13 pi over 6.
is that inside the unit circle or outside?
It's outside.
So if I'm going to subtract multiples of 360, that's
You would want to subtract 12
2
pi, right?
2 pi.
Oh, 2 pi.
There's 2 pi is the same as 360. Well, you're right. 2 pi is the same as 12 pi over 6. So that angle ends up being pi over 6,
Over
which is
6.
30 degrees. So if I'm drawing it, I guess if I'm drawing it, I need to kind of label it like this. Round once,
Yeah.
but it still makes a reference angle of 30 degrees. So if I'm taking the sine of 13 pi over 6, same as taking the sine of 30 degrees.
Okay.
Okay?
Okay.
And I really mean the same there. In other words, taking the sine of 210, not exactly the same as taking the sine of 30. I use
Mm-hmm.
30 as the reference angle, so I know that the sine of 210 is 1/2, but now if I go to put my plus or minus sign on it, I see it's in the third quadrant, got to be negative.
Okay.
So when the same is the same, in other words, 660 is the same as 300. Whereas when I kind of do it by these formulas for the first, second, and third quadrant, I'm not really, it's not, the third quadrant angle is not the same as the first quadrant angle. Because all it does is gives you the equivalent absolute value of the number.
Okay.
Still have to put a different plus or minus on it. But the
Yeah.
sine of 660 is the same as the sine of 300. That same means equal there.
Okay. Okay. So, alright, I see how that goes. Okay. So the next question is asking to find the exact value of each expression.
Okay?
And so it is tangent of 7 pi over 6.
Which quadrant's that?
7 pi over 6, third quadrant?
Uh-huh. In other words, I can label these also as pi over 2, pi, 3 pi over 2, and 7 pi over 6 puts it in the third quadrant. So based on my either the reference angle or the equivalent first quadrant angle, what's the equivalent first quadrant angle? This theta minus 180 when you're dealing in radians is the same as pi minus 180.
Okay.
The second one is the same as, excuse me, hold, I wrote that wrong. 180 is the same as pi, so this is the same as theta minus pi. This is the same as pi minus theta. And this fourth quadrant is the same as 2 pi minus theta. In other words, you don't necessarily have to convert to degrees. In fact, let's not.
Okay.
Using this at the bottom, using that right there, what's the equivalent first quadrant angle or what they would call the reference angle?
Pi over 6.
Okay. And now what's the tangent of pi over 6?
The tangent of pi over 6 is 1 over root 3.
Good. And you're the one that told me your teacher told you not to worry about rationalizing, right?
Yeah.
I love that rule. And is this plus or minus?
Plus.
Because it's third quadrant, tangent's plus in third quadrant. Okay.
Okay, so okay, I see how that goes.
And I just always do it that way. I mean, there's different ways to look at this thing, but I figure out the absolute value first, and then according to all students take calculus, it's easy enough to figure out whether it's plus or minus.
Yeah. Okay. All right. The next one is cotangent of negative 45 degrees.
We're going to need a calculator for that, because notice that is not a multiple of 30 or 45 degrees.
Mm-hmm.
In other words, that's...
Oh, no. 45, not 35, sorry.
I was wondering what was going on here, because that didn't seem like it should be right. Okay.
I know. I just looked at my unit circle. I'm like, 45's on there. Like, wait, what?
Okay, well, that's that angle there. So there's two choices to do this. One is to convert it to its equivalent first quadrant angle. Let's do it that way, just for the heck of it. What's the first quadrant angle?
45 degrees. Is it?
Yeah, it is. Let me take that back here. I didn't really... Here's the two ways to do it. It's the same as the cotangent of 315. Minus 45 is the same, exactly the same as positive 315.
Okay.
And if the problem would have said, what's the cotangent of 315, then what's the equivalent first quadrant angle? 45.
Okay.
What's the cotangent of 45? Well, it's 1 over the tangent of 45. What's tangent of 45?
Tangent is root 2 over 2. Root 2 over root 2.
Which is 1.
Yeah, 1.
That's one of the ones you want to remember. Tangent of 45 degrees is 1.
Okay.
Okay. So that would be 1 over 1, and I can see we're in the fourth quadrant. What is tangent in the fourth quadrant? Tangent and cotangent?
Tangent in the fourth quadrant is negative.
Okay, so that's the answer,
Okay.
-1. But there's actually an easier way to do it. We went through a couple of steps that we didn't really need to go through. And I want to show you the easier way, because once you learn the easier way, you won't ever do it the hard way again. First of all, it's necessary to know that the tangent of a negative angle is the same as the negative tangent of the positive angle, because it's an odd function.
Okay.
Sine and tangent are odd. And if this is true, in other words, if tangent's odd, then cotangent's odd also.
Okay.
The cotangent of -45 degrees is exactly the same as minus cotangent of +45 degrees, which is exactly the same as minus 1 over the tangent of 45 degrees. Well, now I don't have to deal with that 360 minus theta. I don't have to convert it to a 315 degree angle. I can deal directly with tangent of 45 degrees. I know that's 1. And this negative sign is still there. So I immediately get -1 without ever bringing into play the 315 degree angle. All I have to know is that the cotangent of a negative angle is the same as the negative of the cotangent of the positive angle. Well, that positive angle is a first quadrant angle, and the cotangent of 45 degrees is 1. So -1 immediately. And
Okay.
it's quicker using that property of trig, the odd and even property, to do it. Negative angles that way. Same thing if I said, what is the sine of -30? Well, we know what the sine of 30 is. It's 1/2. And if I know that the sine of -30 is the same as minus sine of 30, don't have to worry about quadrants. Sine of 30 is 1/2, therefore that's -1/2. Very fast. And just as a reminder, let me do it the slow way. The slow way would be to figure out that the sine of -30 is the same as the sine of 330. And then reading that 360 minus theta, so that's the same as the sine of 30, so I get my 1/2, and then I figure out it's in the fourth quadrant, so it's got to be negative. So I get to the same answer doing it either way. It's just that this way here is at least one step faster.
Okay.
I do not have to convert that to 330. First of all, so that saves a step. And then I don't have to go and figure out what its plus or minus sign is, because I'm dealing directly with a first quadrant angle the moment I do that. Little confusing, but I think you'll get it if we do a few of these. What else?
So the next one wants us to find the exact values of the 5 remaining trigonometric functions of theta.
Okay.
So it is cosine of theta equals -12 over 13, where sine of theta is above 0.
Now, the second...
sorry, sine of theta is below 0. Sorry.
The second piece of information they give you here, what the sine of theta is, spots the quadrant. There is only one quadrant where cosine is negative and sine is negative. What quadrant's that?
Cosine is negative and sine is negative. That's the third quadrant.
Okay, so let's write that. That's the only purpose they're giving you this information, is to tell you it's in the third quadrant.
Okay.
Okay, so the first thing you do on these problems is draw just a triangle. This may not be the way they do it in class, but I guarantee it's the easiest way.
Yeah, this is the way to do in class.
Oh, good. Draw a triangle. Don't bother going to the unit circle and trying to draw this reference triangle in the third quadrant. That's the hard way.
Okay.
The easy way is just to draw a triangle, label theta. Now give me 2 of the dimensions of that triangle.
2 of the dimensions.
What's the adjacent?
The adjacent one is 12, negative 12.
No, just 12. Don't worry about
12?
the negative yet. In other words, when I say draw a triangle, I'm drawing it in the first quadrant, basically, but I'm really just drawing a geometric triangle. And this has to be 13, right?
Yeah.
Because the cosine of theta is 12 over 13. Now, we know it's in the third quadrant. We're going to take that information into account, but the first thing we need to do is dimension all 3 sides of this triangle. What's the side opposite theta if it's a 12, 13?
5.
Yeah, that's the second lowest Pythagorean perfect triangle. Once I've dimensioned all 3 sides of the triangle, well, now you can tell me all of these. What's the sine of theta?
Negative 5 over 13.
Start with 5/13.
5/13, sorry.
Now it's in the third quadrant, so it's negative. In other words, once you establish a pattern on how to do these, don't do it backwards.
Okay.
In other words, there's no need to come up with the sign first, the plus or minus sign first and the number second. Come up with the number first and the plus or minus sign second. And then they want all the other 5 trig functions. What's the tangent of theta?
Tangent of theta would be 5 over 12.
And what's its plus or minus sign?
It's a positive because it's in the third quadrant.
Okay, and cotangent of theta?
12 over 5.
And
also positive.
Right. Secant of theta?
Negative 13, or 13 over 12, and it's negative.
Okay. And finally, cosecant of theta.
13 over 5, and it is negative.
And that's how you do it. And notice that at no point did we figure out what theta was. Because that is another way to do it. It's not the correct way to do it. But if I went up to here and I wanted to know what theta was, I would take the inverse cosine of negative 12 over 13. That would tell me theta from my calculator. And then I could go in and take the sine of that angle, the tangent of that angle, the cotangent of that angle. So I could solve this problem by figuring out theta, and it's a different method of solution and not nearly as good because it's not exact. In other words, if you get theta here, it's going to be an irrational number with 9 decimal points, odd infinitum. So you're not going to be able to put it in correctly to figure out what the sine of theta and tangent of theta and all those is. So this is a much better technique here, where you figure out those 5 trig functions without ever knowing theta.
Okay.
And this is probably the quintessential problem of trig. If somebody was going to give you a trig test and they could only ask you one question, it would be something like this. In other words, they would give you 1 trig function of an angle and give you enough information to figure out what quadrant it's in. And then they would say, what are the other 5 trig functions of that same angle?
Okay.
So these kind of questions you really want to know how to do because you're going to get them a lot on tests and things like that.
Okay. Okay. Okay, the next problem is a word problem.
Okay.
So 42.
Go ahead and read it.
Sorry.
I'll try
yeah.
and draw the...
Okay. A coin is dropped into a funnel where it spins in smaller circles until it drops into the bottom of the bank. The diameter of the first circle the coin makes is 24 centimeters. Before completing one full circle, the coin travels 150 degrees and falls over. What is the position of the coin relative to the center of the funnel?
Wow. That is a word problem for sure.
Yeah.
All right, let's see if I can draw a picture of it here. There's the funnel, right?
Yes.
And the width down here is 24?
No. I think it's the diameter of the first circle the coin makes is 24 centimeters.
The diameter of the circle that the coin makes.
So, like, they, rolled the coin in and it spun around the funnel.
In other words, that right there is 24 centimeters. Here's the coin over here. And the diameter that the coin makes is 24. So the funnel would have to be at least, well, no, it wouldn't have to be at least, but...
No, I think it's the coin spinning around, and then when it drops, it just goes in. The coin itself isn't 24 centimeters.
Okay. So the coin is spinning around, and when it drops through the funnel, it's making an angle like that.
No, I don't think so. I think it's when the coin's spinning around the funnel, when it makes one full complete rotation, it is 24 centimeters in diameter. When it makes one full complete rotation around the funnel.
For some reason, I'm having a hard time picturing this problem as to what you're talking about.
Have you ever seen at the mall where you kind of drop a coin and it spins around like that funnel until it goes to the bottom?
I have.
Yeah. So
when it's made one complete spin.
Rotation. Yeah. Spin around the funnel. The diameter of that circle that it has made is 24 centimeters. That make sense?
Not really.
You want me to read it one more time?
Yeah, maybe that.
Okay. A coin is dropped into a funnel where it spins in smaller circles until it drops into the bottom of the bank.
Okay, hold on. Let me just see if I'm interpreting that correctly. So in other words, the coin's dropped here, and then it goes like that, and then it goes like that, right?
Yeah, it's like spinning around.
They're saying that first spin?
Yeah, it's 24 centimeters.
So that's 24 centimeters?
Yes.
And then when it finally drops through,
it has traveled 150 degrees in that circle.
Okay. Which means, in other words, it hasn't made a full revolution.
No.
It's only made not even a half revolution. It's made 150 over 180. 5/6.
Mm-hmm.
Not even 5/6, 5/12 of a revolution. Still not sure how to do this. For some reason, this problem befuddles me, and I've never come across anything like it. I've come across problems that have befuddled me, but I've never come across a problem quite like this, where I can't seem to picture it in my head what these numbers are referring to.
Yeah, it's kind of interesting because then they ask, what is the new position of the coin relative to the center of the funnel? Let me see if my book has any explanation to it.
Is this a bonus question?
Kinda. It's the only word problem that we have, and he's gonna go over it in class if we don't get it.
Yeah, I hate to waste any more time on it if you have others.
Yeah, that's okay.
Well,
I wouldn't want to either.
For some reason, I'm not understanding this, and I can't even draw a picture of it. I'm not figuring it out. So
That's okay.
I hate to waste your time when I can't figure it out, but you got another one?
Yes. So the next one is find the exact value of each expression, and if undefined, write undefined.
Okay.
So the first one is sine of 315.
What's the equivalent first quadrant angle?
Pi over 4?
Okay. If we're starting the problem in degrees.
Sorry, 45 degrees.
Yeah, let's leave it in degrees. In other words, it is pi over 4, but that's fine. And what's the sine of 45 degrees?
Root 2 over 2.
Or 1 over root 2.
Yeah, or 1 over root 2.
The fact that you told me root 2 over 2 leads me to believe that when they taught you these two triangles, they labeled them root 2, and 2 for 45, 45. Because that comes ready rationalized when you use this triangle over here. In other words, you actually end up with root 2 over 2.
Mm-hmm.
I'm surprised they did that because your teacher said he didn't really care in trig whether you had an irrational denominator, and I agree with that 100%. You shouldn't care. So it surprises me that they give you this as the triangle instead of the one that I gave you, which was 1, 1, root 2. Notice that they're the same proportion. If I take my 1, 1, root 2 and multiply each side by root 2, I get this one. The difference is that when you use my triangle, everything comes out, sines and cosines come out as irrational denominators. But notice that secants and cosecants come out rationalized. In other words, the secant of 45 is root 2 over 1. Whereas if I take the triangle that's labeled root 2, 2, and I said, what's the secant of 45? You would say 2 over root 2, right? Which has the irrational denominator. So it's fine. Either one of these triangles is correct. Remember, trig is all about ratios. It's not about absolute sides of the triangle. It's about the ratios of the triangle. So that's fine. That's a correct answer. Now, what's the plus or minus sign on it?
It would be negative.
Correct, because it's fourth quadrant.
Okay.
What else?
The next one is the secant of 3 pi over 2.
Okay. What angle is that?
That is 270 degrees.
So that's 1 over what function? What's its reciprocal?
Oh man. 1 over 0?
Reciprocal of secant.
Yeah, so it's 1 over 0.
Well, it's cosine.
Oh, 1 over cosine, sorry.
Start with
270.
that. And then the cosine of 270 is 0. So we've got 1 divided by 0, so this one is undefined.
Okay.
Okay. Remember this about trig, that there are numerous places where the sine and cosine are equal to 0, and every time the sine or cosine is equal to 0, then its reciprocal is going to be dividing by 0, so the reciprocal is always going to be undefined.
Okay.
So the secant and the cosecant curves have vertical asymptotes, lots of them. Every single place. In other words, if I draw, say, the sine curve, every single place that is 0, there's going to be a vertical asymptote on the cosecant.
Okay.
Because at each of these spots, the cosecant is going to be division by 0. And so if I'm drawing the cosecant curve, it goes on the peaks of the sine and the valleys of the sine, and it's asymptotic with these vertical asymptotes. And this is 180, that's 270, and that's 360. So if I'm talking about cosecant, then the cosecant of 0 is undefined, the cosecant of 180 is undefined, and the cosecant of 360 is undefined.
Okay.
And when I'm talking about secant, that sits on the tops and bottoms of the cosine curve. And so it's not going to be the same places where it's undefined. It's going to be undefined wherever the cosine is 0. In other words, if I draw my cosine curve, there's these spots where it's undefined, where, the secant would be undefined. And that spot is 270 degrees right there. And the secant, remember, sits on the tops and bottoms of the cosine curve. So you can see that at 270, that thing's headed towards negative infinity, which is what undefined means. Undefined means either positive infinity or negative infinity.
Okay. Okay. Yeah. The next one is cosine of 7 pi over 4.
Okay. Hold on. What quadrant is that in?
That is in the 4th quadrant.
Okay. What's its equivalent radian angle?
Equivalent radian
Equivalent,
angle.
what's its reference angle?
Well, pi.
Pi over 4. And
Pi over 4.
Things are equivalent. When I say what is its equivalent first quadrant angle, that's the same as what is its reference angle. In other words,
Okay.
this is the reference angle right there. Now, what's the cosine of pi over 4?
The cosine of pi over 4 is root 2 over 2.
And what is its plus or minus sign? Which quadrant is it in?
I mean, minus?
Which quadrant is 7 pi over 4 in?
Oh, 4th quadrant. It'd be positive.
Positive. All students take calculus. That's why I always do it in a multi-step process. I figure out the number first, then I figure out the sign, and figuring out the plus or minus sign is real easy. is all you have to know is all students take calculus and which quadrant you're in.
Okay.
Okay?
Okay. The next one is negative 19 pi over 6.
Which trig function?
Oh, cosine, sorry. Cosine negative 19 pi over 6.
Well, the easiest way to do this problem is to use the fact that cosine is an even function. So the cosine of a negative angle is the same as the cosine of the positive angle. So I can immediately write that. That's my problem, to figure out what that is. Now, is that inside the unit circle or outside? By outside, I mean greater than the unit?
It's outside.
Okay, what's its equivalent inside the unit circle angle?
7 pi over 6?
Yeah, I can take away 2 pi only, and that leaves me that. So now the entire problem becomes this down here. You can cross this out. This is what my problem is. What's the reference angle for 7 pi over 6? First of all, what quadrant is that in?
That's the third quadrant.
Okay. So what's the reference angle?
The reference angle is pi over 6.
Okay. And what's the cosine of pi over 6?
I think that would be negative.
You're right.
Yeah,
negative. What's its number?
Negative root 3 over 2.
Okay. There's your answer.
Cool.
Oh, hold on. Hold on a second. Yeah, no, that's correct. Yeah. Yeah. This is easily the best way to do it. Or you immediately use the odd even property. In other words, by using the odd and even property of these trig functions, you can basically handle this difficulty of dealing with a negative angle.
Okay, yeah.
Okay. All right, Nick, I'm going to let you go because I have a 4 o'clock I got to get to.
Oh, yeah, that works great because that was my last problem, actually.
And I'm dying to hear the answer to that funnel problem. And,
yeah, I'll ask him about that.
The description of it, because I can't even picture what it is that he's trying to say by the word problem.
It's interesting. I don't know. I'm not sure either.
That's an interesting problem. I'm not sure what he's saying with it. So I will talk to you next time.
Sounds good. See you later, Ms. Cohen. Thank you.